So, hello, ladies and gentlemen, my name is Varik.Verilion, and I think we are live, right? Yeah, we are live. Okay, yeah, so today we're going to be reading about predictive processing, just like how last time we were at it, right? So, yeah, like Surfing and City by, what do you call that guy? Like Andy Clark, right? And his book is kind of marvelous because it gives us an idea about, like, a lot of things, right? So, like, yeah, we would be going on with that, though. Right. Like, yeah, so I'm sharing my screen and I hope you guys would be able to see what's going on the screen, right? So, like, yeah, I've got 27-inch monitors. If you're watching this from a phone, that would be pain in the ass because you would not be able to see literally anything, right? So that's kind of sad for you guys, kind of. Let me just kind of like does a setup. I mean, you can have like a slight area here to kind of like write and take notes, and we can just connect XP pen to, right? XP pen, please connect the device first. Okay, the device is already connected. I don't know why it's showing the error. Let me just plug it back though. Yeah, it shows that. And I'll just can change the work area, guys. Wait a sec. Right, so we open it up again. Yeah, let's go with the primary monitor. And I think we should not go with the top. We should go with a 90. Yep. Perfect. Almost perfect. Yeah. So, yeah, now we need to get our pen, which is almost here. Right. So I think we should be able to write everything. Right. So, yeah. All right. And we should be able to draw, right? Okay. Yeah. Working with low sensitivity and constantly changing the sensitivity has a toll on my hand too, right? It's like hard to, but yeah, so we won't be able to write anything and we won't be able to go beside, like, yeah, as you can see, we are not able to go besides the wall or something. So, yeah. My name's Varik. What do you want? Or shall we, if you go with the whole screen, then there's another problem that comes up there. So, like, yeah. Hmm. Yeah, so I'm pretty much good visible. Hello. So, yeah. Then I guess it's time to get started with predicting processing, right? So, dealing with structure, prediction driven multi-level learning is another key shot for early propagation of error-based connections and treatments. Their lack of principal meaning of dealing with structure. This is the need to represent and process complex articulated search and hints such as the part of full hierarchy, structure true in which elements from, like, themselves elements or something. I just want to see one last time if my face and everything is all right. Right. So, like, yeah, we should get this somewhere like here. Right. Why do I feel like cold? Let me just increase the temperature. Structure such as. Sorry for the noise again and again. I think I have an idea. Wait a sec, guys. Like, this is something I have not done before yet, so I may not know much of it, but yeah, so it kind of like creates blue light. Mbox, cinema, game, e-paper. Right. And if we increase the brightness, I want to see though, like, oh, now it looks so much easier to read. Does it appear exactly like that on the screen too, I suppose? I think so too, right? It does. Let me get a real live example of it. Ah, it doesn't. Oh, so it's like a filter only I can see. Well, that actually is kind of like great. Right. It's like a filter only I can see. That's actually good though. Right, you guys can still see all the colors. So for you, it's like the same. But what I've done is like I've actually made an e-paper or something. So what it essentially does is like, just like the name suggests, it's like now an e-paper, just like how you have in Kindles, right? So, and let me just kind of like up it up again. Yeah. So everything now is working. Let me just on noise cancellation. Classical identification. Hmm. What the fuck are they saying? This book would heavily require us to use ChatGPT. I'm not even kidding at this point. Like this book would require insane amount of uses of ChatGPT and different AI or something. Like the answer is pretty simple because like this is a really really complex book, and we would be going to our different project, informative edge, right? Oh, the photo didn't get transported there. That's all right. Yeah, I need multiple monitors right now. I just realized. Okay, the need to deal with the principal manner with structured domains. Actually, right now I would be putting it here down because like yeah, this would like hinder my ability to see my stream. But yeah, last time someone did came and I wasn't able to talk to them. This is kind of not good though. So we would actually have something like this set up where this goes down here or something like yeah. Principle, right? So the need to deal with the principal manner with structured domains to release skepticism. Okay, so I'm reading Predictive Processing, and this is a like a paragraph from the book called Surfing Uncertainty by Andy Clark, and it's like the chapter one. And like, yeah, could you help me understand what it says? Surfing Uncertainty. I'm reading Predictive Processing. Right. This is important in structured predictive processing. Like I don't need to get everything, but yeah, it is a strategy of using top-down connection to try to generate using world knowledge, a kind of visual version of sensory data via deep multi-level cascade. Predictive coding approaches to interception. Paragraph is about the problem of old classic AI had. It's trying to solve it different. Let's unpack their lack of principal means of dealing with a red cup in a wooden table inside a kitchen. This isn't just it's a structure. Next to another, this is called pothole hierarchy. The world is full of these cells, tissues, organs, letters. The brain somehow has to represent these nested relationships. The classical AI is a conventional simple approach to system of pointers. Imagine. half hidden. Right, someone says, can you get the mouse? Reinterpret meaning from context time. To guide behavior in time pressure real world setting. Imagine catching a cricket ball. You constantly compute velocity, gravity, wind resistance ahead. Continuously hundreds of thousands. Why this matter for predical is preparing the motivation and the place explaining symbolic taste. Either confirm or correct those predictions of interacting predictions. Ah, lower level creates upper level predictions. Okay. Flexibility when the world is noisy, ambiguous, or changing the ideas. It is that twist, the strategy of try to generate using well knowledge a kind of vulture version of century data via deep multi-level cascade. First in 2005. Kill predictive coding or predictive processing called combines the use of top-down probabilistic generative model with a specification of how and when such influences might operate. Okay, sorry, I should have like the link. Oh, it got highlighted. Wait, it's really hard to see highlighted parts with e-paper ability on because like yeah. Top-down generate specific vision of how and when such influences operate, borrowing from commercial work in linear predictive coding. Top-down and lateral flow of neural signals as constantly, not just during learning, aiming to predict the current sensory pairs, leaving only an unpredicted element in this prediction area to propagate information forward within the system. Okay, now we also need this. Like, this is something, guys, I'm telling you, in this book, we are gonna be using a lot of screenshot for AI to explain us what the fuck, like, is even going on here. Right, because, like, this is one of the most dense book, and pretty honest, not the guy. So yeah, what they talk about is like first of all we had representations. It's like what they're talking about is like symbolic, right? This is what like we also talk about in Freudian or was it like I don't know Freud or Jung, like they talk about the symbols and how brain thinks in terms of symbolic. But what they're saying is like it doesn't think in terms of symbols or association or pointers, but it actually thinks in terms of like yeah because there's every like in probabilistic predictions, right? So as soon as you add probability rather than symbolicness, because like yeah probabilistically it's like this is a cup and there's a high probability that this is a cup on the prior data I have, so I'm predicting this is a cup. But if symbolic it's like okay this should be like symbolic means like there is some universal cup. And yeah the probability in many ways we are about to explore to neural domain. This makes prediction error into a kind of proxy for any as yet unexplained sensory information. Prediction error here with the supplies include by the mismatch between the sensory signal and those are prediction. Yeah, this is something we already know from the first, second chapters, but yeah. But they are also first and like yeah, so at least it's grounded in Fisher and free energy principle. This make the prediction a kind of proxy for as not yet unexplained sensory information. The action here reports the okay, what's happening guys? Wait a sec. Surprise induced by the mismatch between the sensory signal encounter and those predicted. Right, more formally, we have more formally and to distinguish from surprise and normal experimentally, since this is a kind of a surprise type. As mentioned earlier, I shall describe such systems as engaging and I do get what he's trying to say though, but yeah. And thus speaking of predicting processing rather than right, I mean I should do that now. It's not working out, guys. It's like I'm not able to highlight anything. So I will change my from e-paper to simply. Even then I won't see, but yeah, this is actually better. Yeah. This is great. As mentioned earlier, I shall describe the system as engaging and thus speaking predictive coding. Yeah, predicting rather than resting with the more common uses. Predictive coding, which I mean to highlight the fact that what distinguishes these approaches is not simply the use of data compression strategy, more on which shortly known as predictive, rather than it is the use of strategy in very special. Then resting with the more common predictive coding, I mean to highlight the fact that what distinguishes these approaches is not simply the use of data compression, just use of strategy in very simple context of hierarchical. Generative models. Such systems exhibit powerful forms of learning, and as we will later see, driven rich forms of context-sensitive processing are flexible to combine within the multi-layer cascade. Predictive coding was first developed as a data compression strategy in signal processing. Thus, consider a basic task as image transmission. Most image the value fund regularly predicts the value of its neighbors, with difference marking important features such as boundaries between objects can be compressed for properly informed receiver by encoding only the unexpected variations where the actual value departs from the predictive one. The simplest prediction would be share the same value, the same grayscale value, for example, but much more complex predictions are possible. As long as there is detectable regularity, this particular form of data compression is possible. It is the deviations from which is predicted that carries the news, quantified as difference prediction error. The actual current signal and the predictive one. This affords major saving of bandwidth. I've already highlighted this one. Yeah, I've already highlighted this one. For the company major bandwidth and economy that was driving force behind the development of technology. Data compression by informed prediction allows quite modest encoding to reconstruct into rich and of original sights and sounds. Such techniques so much of them in the previously processed frame. Take the case of moving object against a stable ground. There, most of the background information for the present frame can be assumed to be same as the previous one. Camera pens, nor is the technique limited to simple predictable transformation of moving object can themselves be factored as long as the speed or even the rate of acceleration remains the same. Prediction and thus all the information required to construct frame 2 of a very simple moving image might already be present in the frame 1 with compensation applied for motion. Leave the second frame, you would then just simple as same as before except move everything 2 pixels to the right. In principle every irregular change should be predicted, leaving only truly unexpected deviation. The emergent take is thus trading intelligent knowledge against the cost of action or expectation. All that matters is that the receiving system be able to reconstruct most of whatever irregularities have been detected. But then again, like guys, I think there's some problem. Yeah, we have add that snippet, right? Yeah, which cross we'll actually add another like this, add a new. Get a lot of what he's saying, but then I still don't get almost all of it. Control V. I need multiple monitors. I'll say that a million times, and I'll get them tomorrow, I guess. Yeah, and I don't like the coding. I mean, I'm gonna change this a million times at this point, man. I think what I liked the most was not e-paper, just a user simple one. No, this is just too much on my eyes. Standard, okay. Let's go with standard, man. Standard is just kind of awesome. Okay, maybe it was because of blue light filter that way, like coding. Nah, coding is just too dark, and it expects me to be in a dark room. Maybe care mode works. Yes, care mode works. Yeah, but you guys won't see any difference because, like, yeah, the OBS doesn't record. Like, it's a filter on the screen. It's not like, yeah, OBS doesn't record the filter. Or maybe it doesn't, like, the monitor doesn't itself transmit the filter. That is actually great. Right. If this runs out, I have Gemini. So yeah, knowing bandwidth and usually knowing the world better. Predictive processing just combines the use of the multi-level bi-directional cascade, the top time prediction generated model with coding self-efficient coding and transmission. Storage on the then perception is indeed a process in which we or other various part of our brain try to guess what is out there. Nuancing the guesses rather than rich and bandwidth costly. Say this does not mean, of course, that perceptual experience occurs only if full rich percept here takes sharply only when downward prediction match the incoming essentially at many levels, but this matching, as we'll see later, is itself a rapid perception of general nature of gist of the scene may be accomplished using a wall-side feed-forward sweep that is sensitive to simple. Emerge concurrently with the progressive reduction of reducible error signals calculated related to top-down prediction. The ongoing process of perceiving if such models are correct in matter of the brain using stored knowledge to predict in more refined manner the patterns of multilinear response allocated to current simulation. Underlines the surprising extent to which this is clear of our expectation, but thus be exploring two distinct but overlapping stories. As a general. The other is one specific, bro. Let's just see what ChatGPT has to say. I do get the part where he talks about encoding, right? So like it's like you give a model like image and a lot of information is already present to make the next prediction, right? And they just need some simpler formula, basic rules, like, you know. But I think even then, you know, like if, so let's say there's a person moving in a video, it's like extremely unpredictable to a simple model, right? I don't get why they say like there's already enough information to predict what's going to happen next, because like honestly, you know, how can a model know? Like, yeah, model can have crude what they say crude heuristics about, you know, like predicting what's gonna happen next. Like, yeah, so you can have like simple rules that the model can actually use on the initial image to actually predict what's gonna happen next, right? But you see what I'm trying to say, right? I mean, it's like even then, like as long as there's like if you put like a box or something like a ball, or throw a ball in the video out of nowhere, which is an object that the model didn't expect or something, it's like it creates massive uncertainty for the model and it doesn't know how it functions. But I still don't know like how can you use just a simple model to predict what's going to happen next, like when it comes to even images, right? I mean, like, yeah. And there's also a lot of part that, like, yeah, some part here and there that I may not get, but you get the gist, right? To a lot of things. And I guess they also keep on talking about hierarchical level of predictions. It's like brain make predictions over predictions, right? It's not just like, for example, you predict how the mouse is going to move, and then you predict how the moving of a mouse moves onto monitor, and then you predict how monitor, may actually, like if you click something using a mouse, right? You predict at one level, and then you predict something what's going to happen next on the monitor, because like, yeah, that's hierarchical level of prediction. You make a first prediction, on the top of that you make another prediction on the basis of the first prediction, right? And it's like, yeah, so yeah, it does function like that. It's like there's some prior predictions, and over those prior predictions there are like, higher levels of predictions, which you kind of like give example to. So it's like prediction over prediction, or maybe it's something else entirely according to the book, or according to the, like, yeah, Andy Clark, I don't know. Andy Clark. Yeah, that those are related, but they're not the same thing. Can't forget. You're fucked. Ah. The highest level predicts only the kind of structure. The highest level predicts context situations, and middle levels predicts only. Mm-hmm. But there's one thing you talked about, which was bandwidth. I think bandwidth comes from information theory, right? Or something. I don't remember though. And you said it saved enormous bandwidth. So are you saying the brain also trying to constantly save an enormous bandwidth? Like if the sensory data is actually like, as it expected, it doesn't put much effort into like, predicting it, but it actually pays a lot of energy and effort into like predicting like a snake. Like suddenly you give the example, right? I can enter a room, there's wall, decks, laptop, door, curtains, right? And then suddenly there's a snake. So it put a lot of energy onto like on computing the error you know rather than like investing onto what is already predictable, which saves a lot of bandwidth, like you said. Like, and here bandwidth in biological system would be most probably like in machines it would be ram, but in humans that would be like glucose and stuff like that, which is like carbohydrates and energy used to like make your body work, something like that. No, AC is kind of going too fast. We're not putting in a time. Engineering bandwidth means okay. Okay, that was accidental. Couple of distinctions. First, what bandwidth mean? Engineering bandwidth. How much information? Imagine internet cable if you can send when that is bandwidth. Optic no, it has. It sounds like a lot, but compared to the amount of information hitting your retina, so it's a severe bottleneck. Okay, millions. So as to compress, that's exactly why Predictive was invented in engineering. It's almost identical. Instead of entire frame, entire cent frames. These pixels in same frame. That's predictive coding. Clock is saying the brain use. The brain trying to save, yes, but not only that, simultaneously saving several scarce resources. Neural communication balance. Neural cannot. Everyone else signals are relatively slow. Connections are finite. Predictive readers how many needs. There's the entire visual scene, the lore. Everything must expect this corner. Brain has only about 2% but consume 20. Neurons are expensive. Every action potential cost APT. Every synaptic cost APT. So yes. Like even this reading of this book and stuff like that costs insane amount of ATP or something, which is kind of like true. So like energy, that's why I'm feeling like eating an egg or something, right guys? Like this book is one of the most hardest book we'll ever complete, right? This is like one of the most hardest book in my entire life. I'm not gonna kid. Like as soon as I get through the first chapter just by using ChatGPT and something like that, I just knew that this is like a really insanely tough topic, right? So computation, imagine processing every pixel independent, that would be incredibly. Ignore. Wait, snake, most processing gets reused. With limited, you cannot consciously analyze everything. Prediction lets attention concentration. Concentrate on surprise, right? That's why attention allocation. You have like attention allocation and stuff like that, which kind of like, okay, why I'm feeling so cold today in my room. But I guess like, attention allocation. So it's like, wherever your attention is going, it will give you surprises, because like and then you would update the model. It's like books gives a lot of surprises, and that would give a lot of errors and in turn update the model rigorously. But then again, like, it's like, let's say if you are like, you may be like into philosophy, and then you are into tons of the idealist, and how do we believe what is true, and then you ask the nature of things and stuff like that, and then you lose, like, because you're attentioning, you're paying attention to, like, okay, how can we even know what is true? How can we know that the brain has even the ability to understand and something, right? Then how are we even functioning or something like that? It's like attention given to very fundamental of things, and it's like, at some case or to some degree, you can never really know those answer to those questions. That's why philosophy just never ends, and people just come with more and more jargon that doesn't make any sense and isn't like explaining anything away, right? Doesn't reduce any surprise, doesn't improve the model in a way that gives more predictive leverage. It just makes you ask more and more questions that can never be answered. Imagine walking into your room, your brain predicts prediction. Notice what happens. Your pupils change, your heart rate, right? Attention locks in, memory systems engage, motor systems prepare. Why? I think that this matters. Brain puts a lot of into predicting the stake. Almost. Prediction and expected sensory input. A large prediction. Just snake really come on how and what it can do. You're predicting what it can do and how it harms you, so you're reorganizing because your prediction says there's a high probability that it's dangerous, and dangerous means, like, yeah, and if it's dangerous, the probability is like there's damage, and like, yeah, the probabilistical model will reorganize you. Works this way. Everything suddenly bang, prediction error, almost. If say yesterday I drank a cup of your brain predict coffee, tea, water, gasoline. Prediction area attention spikes. Yeah, the deeper connection of it. This is exactly why you thought of the Shannon showed something remarkable. Predictable information carries very little new information. Suppose every day I text you, the sun rose today. After a while, the message contains almost zero information that is completely expected. The sun did not rise. The message contained enormous information. The prediction error and Shannon information are deeply. Aha! It's like what happened to the guy who wrote. What happened? More information it carries. This is why Clark repeatedly say prediction error carries the news. Everything expected is already encoded inside you. Only then expected needs transmission. Efficient system turns unexpected information efficient. Okay, I think you'll enjoy one more connection between these types. Several books you've been reading. I've never come research Shannon, though I have got like cybernetics a little bit from Ashby. Efficient system use feedback to correct deviation, which is information, and that means information. For Colin, the brain constantly predicts sensory input and use prediction error. So by reducing uncertainty through feedback and adaptation. Underlying pattern from different angles. Don't spend resources presenting or communicating what you already know. Focus computation on what violates your expectations. That recompense is one reason that these all fit together so naturally. Yeah, that's why reading one kind of book, like reading about brain and brain and brain again and again, it's not going to give you a predictive edge. But reading someday, because it's like there's a lot of information you already have and a lot of expectations you already have about the brain. But then again, I think the one reason why researchers get obsessed over brain or certain specific body parts is like they constantly violate predictions, right? But yeah, but what they are talking about here is also kind of really true, right? So it's like if you are exposing yourself to certain specific thing that constantly violate your expectations, like literally violate a lot, right? And that's gonna update a lot of a lot of prediction model or something, and there's gonna be a lot of salience. But if you are eating something that doesn't violate or takes a lot of energy in brain, it's kind of like running on fumes. So yeah, that's kind of true. Signaling the news. That's why we have like the more the prediction errors you have, the better it is. But yeah, you get the gist. But prediction error spikes uncertainty, and they kind of like force you into reorganization, which is another great thing. It's like, yeah, the more prediction error about your life, about your future you have, the more you'll try to reduce it. And the ways of reducing prediction error, which causes stress or something, is like can be dangerous too, like using porn, Instagram, drugs, or something. Which is your ways to reduce prediction error, which is not reducing any errors, which is just causing you to numb yourselves because you can't reduce the error, so you want to escape from the high levels of cortisol, something, and it becomes a mechanism, right, or something. we have regulation that alters state in the short run but doesn't alter the state in the long run, so you get feedback over the state alteration and then you start using it. But then again, that kind of regulators destroys in the end. The only efficient way to regulate yourself is building a model that reduces long-term uncertainty about the future states or something. To put some example-based flesh on all this, consider the first station of the basic predictive governance strategy network in the routine. At the starting point of the account is well established and take part in some form of predictive coding insofar as the perspective antagonism. What this means is natural. Neural circuit predict on the basis of local image characteristic, and the likely image characteristic will display similar image intent and subtract this predictive value. Actual value. But the difference between raw values and prediction values. I do need to know information theory, like how everything is information. This is the first demonstration of the basic predictive coding strategy in retina. Well established since in retinal ganglion cells that take part in some form of predictive coding insofar as the receptive fields display centers around spatial and as well as a kind of temporal antagonism. What does that mean? What does what mean? Control C. Copy. I think I copied the entire link or something. Oh yeah, it's here. I don't need that. Antagonism is like more like villainism or something. Antagonism. The meaning of is like force, tendency, or principle. Active hostility or position, right? What this means is the neural circuit predict on the basis of local image the likely image characteristics of nearby spots. Basically assuming the nearby spot will display similar image. This predicted value from the actual value what gets encoded is thus not the raw value, but the difference between the anyway ganglion cell signals, not the raw visual, but the departures from the predictable structure under the assumption. Uniformity, right? This is like for example right now slight noise, slight construction noise from the background, like because there's like a construction like what they call the there's like a garage or something that kind of like a furniture house where they build furniture. I don't know what they call building furniture though, but yeah. So there's constant noise sometimes come at the different times of the day. They're like a little bit noise, not too much, which is not problematic, right? So yeah, if I hear that kind of noise from the background, there's a high chance that I may not feel anything. But then again, like if I heard like a boom or something like that, then I would be like that would create a massive surprise, right? Like what happened, what caused the sensory input to come in or something. These computation of predicted salience might have been made solely on the basis of average image statistics. Such an an approach would, however, lead to trouble in many situations. Consider the problem. I need to go to washroom. Just wait a sec, guys. Just 1 minute. Yeah, so it's more like imagine you are in a war, right? And then you have a family, and then there's bombs that's coming upside or something. Like right now, if I heard a bang sound, which is like not too much, in fact, even then my attention would be diverted towards like the building furniture thing. That's like yeah, the people, and I'm gonna think like okay, are those people all right or something, right? And like but if it's a war and if I hear bang every day, I'm not gonna feel much because like it's gonna be a common, but I'm gonna keep track of like when it's kind of like bomb, when the enemies are bombing or something, because that kind of like determines like the health and the life and the risk. And if if the intensity of the bomb increased, then we're gonna um keep track. Like you're gonna be scared shitless, and when it's like yeah, like when the bomb is gonna fall on us or something. So each time a bomb appears, you're gonna keep track when it appears, what intensity, how much time, how long, how many, right? And then we're gonna predict that, even though that what's like how much bomb that there is, but like predicting like their routine would never actually gonna give us like any idea about how much bomb they have. Like it is like a not a good information, but it is an information that pretty much tells us that something really bad is happening around us, and we need to reduce that uncertainty about our future states, because like it creates uncertainty. That the environmental uncertainty creates uncertainty about our future state, so we would be trying to reduce that. Yeah, so we are predicting ourselves, predicting our reality, predicting all these different sensations. So I'm predicting that okay, I would wake up early. I'm predicting that I'm gonna eat, in the afternoon. I'm predicting I'm gonna get my food at night. So what I should do, what I should actually make or something. Like everything is predictions. Predicting my future, predicting like okay, first of all, take this example. Like when I was drinking the water bottle, I predicted, I was almost sure that how the water would taste like, right? What it will do to my trust. Like let's say for example, I drink the water and I realize there's a lizard in it. That's a massive surprise. I'm gonna throw off the bottle, maybe get a lot, and then start look like that. My stress gonna rise, cortisol may spike, my body may get tense to kind of like get in response to do something to the lizard in the bottle. And if it's in my mouth or something, that's gonna be something like a massive surprise. In fact, and then I'm gonna start predicting how did the like the lizard even got in the bottle, what actually caused it to get in there and stuff like that. At which the nearby points in space and time are typically similar because they stick properties of different types of scenery. And we move from inside a building to a garden or lake. Vary as a result of adaptation to correction. So now what the fuck they're doing with lizards, man? What the fuck are they doing with lizards? Yeah, so they kind of like took lizards or something and did something with them. Uh, from learning in which correlate activities cross and leads to. Oh, sorry. Plausible way to implement this mechanism, but there are no a plastic and connection that in turn alter receptive fields if as to suppress the most correlated components of the stimulus. In summary, cell seems to be engaging in computation, expressive process of dynamic predictive recording of rhyme. to strip from the visual stream predictable and therefore less trustworthy signal. Whoa, the is this reduction? Okay. Let's unpack first. What is Clark is talking about retina. It's not retina. It's already doing computation before even information even reaches the brain. One of the last neurons in retina is ganglion cell. Those ganglion cells send signals through the optic nerve. What do ganglion actually send? The old idea was light hits retina. Retina measures brightness, sends brightness to brain like a camera. The predictive coding idea, Clark says that's probably not what happened. Instead, light hits retina nearby pixels should look like. Compares prediction with reality, only send the difference. That's huge difference. Image, every pixel is almost, if one pixel is gray, the neighbors are probably gray too. So the retina predicts, okay, the pixel should be, it looks gray. 0, nothing interesting. Now imagine suddenly one pixel different, now prediction gray, reality black, prediction at the clock says getting a sense signal, not the raw visual image with it. This is exactly gray. What does this say? But imagine transmitting this very visual, except it's a much smaller message. Clark introduced something new. This is the really interesting part. He says ordinary predictive coding still isn't enough. Why? Because the environment changed. Imagine you're inside walls, furniture nearby. The use crowds, but everything is different statistic. The rules change. If your retina kept the indoor prediction rule, it would perform badly outside. Therefore, the retina adapts. Clark says dynamic predictive coding, meaning, oh my gosh, brain is so like, since itself change. Yeah, where is the dynamic predictive coding, man? I'm not kidding, man. So now you have a system that kind of like prediction sends only the difference rather than actually sending like the entire thing. It saves bandwidth in computation, right? Imagine your retina inside most nearby complex are smoothed up. Lots of texture now. Different prediction models, same retina. Lots of texture now, different. Has different image statistic. Researchers recording they found only for a second about half of the retinal neurons changed. Salamander, right? Not because the animal learned forever. It means if retina itself was already changing its prediction model. Then comes the sentence people usually say anti-human learning. The idea is simple. Normally, neurons strengthen frequently used connection. Cells that fire together. Anti-human is almost if something becomes very common very early, the system gradually separates. Why? Because don't waste competition. Prediction system has the retina doesn't simply measure light. It asks actually if something is expected, repetitive, statistically, it gets a price something amplified. Oh my gosh, yeah. It gets amplified and throughout the life it keeps on amplifying because you must consistently reduce uncertainty about your future states, right? That should remind you of something. Notice how this connects to the snake example. Walking through your room. Walk disk hidden laptop prediction errors almost zero, then huge prediction of the retina. In the higher brain areas, I'll begin allocating more resources there. Everything in the world. Made if the nervous system be less like a camera and more like a newspaper editor. Carry the news. Predicting natural predictive processing takes the biological emphasis on newsworthy several steps further, offering a new take on nation itself and predictive processing scheme. Then giving synchronicity is met by flow of guessing constructed using multiple layers of down and lateral infinite reducible mismatch get caused forward and laterally. Functional asymmetry between forward and backward pathways. Functionally speaking, between raw data seeking explanation bottom up and hypothesis seek effective downstrip. Each layer is such a multi-level. Oh, I wasn't showing my screen. Fuck, forgot about that. And so look at this high-level prediction, increasingly abstract. Bottom up flow of inputs, unexpected input, prediction, prediction. Top-down flow of prediction. A highly schema view of predictive processing. Inputs are processed in the context of priors. Higher up in hierarchy. Paths of input errors travel up hierarchy, leading to adjustment of subsequent prediction. The cycle continues. Their hierarchical system treats activity in the layer below as if it were sensory input, with a flow of app top-down prediction. There are several worked examples of this in the literature. Here review by Hung Rao and Ballard 1999 provide the seminal proof of concept. In this work, prediction-based learning targets image patches drawn from a multi-layer artificial neural network. Okay, my concentration was actually provides the seminal proof of concept, right? Yeah. In this work, prediction-based learning targets. Prediction-based learning targets. Imagine patches down. Okay. My brain, man. In this work, prediction-based learning targets imagine patches down drawn from natural scene using a multi-layer artificial neural network. Multi-layer artificial neural network, the network which has no preset tags apart from that using the downwards and lateral connection to match inputs. There's no preset tags apart from using the downward and lateral connection to match the input samples with successful predictions. Develop a nested structure of units with simple cell-like receptive fields and captured a variety of information effect. So there is some pattern of energetic simulation until it's opposed by sensory receptors from embryo. Current visual scene. These signals are then received via multi-level cascade in which each level attempts to predict the activity below it's via backward connections. The backward connections allow the activity in a stage to provide another input at previous. So as long as this successfully predicts the lower level activity, all is well. No further action needs to ensure, but where here is mismatch prediction error occurs, the ensuring propagated later and higher level. Ah, this automatically recruits new probabilistic representations, so the top-down predictions do better in canceling the prediction at the lower level, yielding a rapid perpetual inference. At the same time, the prediction error is used to adjust the long-term structure of the model, so to reduce and any discrepancy next time around, yielding slower timescale perceptual learning. Forward connection between levels thus carry only the residual errors. Residual error, well, yeah, separating the predictions from the actual lower level activity. While backward and lateral connection conveying the generative model carry the prediction themselves. Changing prediction corresponds to changing or turning your hypothesis about the hidden causes of prediction correspond to changing or tuning your hypothesis about the hidden causes of lower level of activity. In the context of embedded active animal, this means it corresponds to change or turning your grip on what to do about the world. Tuning your grip on what to do about the world or given the current sensory barrage. The concurrent running, this is how they reduce uncertainty about the future state, right? That they do that because they think doing that will lead to a girl or something, right? Or, yeah. This means that spikes uncertainty about the practices they're doing and they must try to reduce it, right? Because brain constantly try to look for the evidences of their behavior and they try to, and it's more about how it feels, but then again, it kind of doesn't stick because, like, yeah. This means it corresponds. Oh yeah, and then there's incentives too, right? The incentives forces a lot of compliance. Embodied active animal, this means it corresponds to changing or tuning your grip on what to do about the world. Means it counts by the changing or tuning. That's why a lot of people are shaped by their parents, whether they like it or not, significantly. Right, but they're shaped by their environments. Like, yeah, parents play a big role. I think this is the thing, right? It's like, okay, there's so much light right now, and I know you guys don't want to see too much light, but yeah, but the main thing, guys, is like, uh, from what I've understood till this point, is like you have you have ways of reducing uncertainty about the future states, and then you have a hierarchy model of representation of reality, and it's like then there's incentives which kind of like biasing. So like, okay, you need to reduce uncertainty, but it's not about you complying or not complying. The one of the most efficient ways to reduce uncertainty about your future state is by complying to what your parents are saying. So that could mean like agreeing to what they want you to do, agreeing to certain specific things, or something like that. So you see what I'm trying to say, right? So what you are pretty essentially doing is like people say it's like, okay, Minger would say, Charles Minger, the one that whose book we rejected, right? He would say it's because there's incentives because what parents are rewarding, but it's more like it's like whatever. It's like, yeah, this is entirely wrong. Incentives are appearing. It's because people have certain ways of reducing uncertainty about certain things, right? And that reduction of uncertainty constantly gets rewarded because like brains cannot tolerate open loops. They must have a closure, and the closure here means a reduction of uncertainty. So for example, I'm still developing this idea and thesis because of the book, right? I'm trying to connect, but you can pretty much see I'm trying to be able to connect. I'm not connecting it perfectly, I know that. You don't have to tell me that. In fact, majority of the people wouldn't even understand how I'm not able to connect it well, but it's like the idea pretty much are connected. It's like, so for example, every time every behavior that originates, a lot of time I used to think, okay, behavior is originating from evolution, but a lot of behavior is kind of like, yes, originating from evolution, and especially about the hard-coded encoded priors that you must constantly reduce uncertainty about. But it's like, yeah, it's constantly like, like, working out because there is some sort of uncertainty there, right? Which kind of like causes that. So yeah, which causes pain and specific things like that, and which is like Highly unpredictable. Yeah. The lower level activity. In your context of an embodied active animal, this means it corresponds changing, tuning the grip on but the world. For example, let's say you don't want to study, but your parents force you to study, and they say they won't give you money if you don't study, or like they hurt you or something. Then you know that if you want some control over the environment, then you have to study. But then there's reward mechanisms, and then you're justifying those rewards consistently by using some form of because your body rewards you for it. So there's like a fundamental mismatch what your parents are trying and what kind of incentives they're making for you, and the games and their rewards. It's like they're giving you access to the games, but simultaneously they're so it's like if they remove the access to the games, then the only viable strategy that is left to actually comply with them and actually do what they're telling you to do or something like that. Respond to changing and tuning a grip on what given the current sensory baggage. The concurrent running of this kind of prediction error calculation with a bidirectional hierarchy. Now you can see running of this kind of prediction error calculation, the bidirectional hierarchy of cortical areas allows information pertaining to irregularities at different spatial and temporal scales. But spatial and temporal scales, okay, to settle into mutually consistent whole, and with such helps tune the rest, as the authors put it. Prediction and predict error correction occur concurrently throughout the hierarchy, so top-down information influences the lower-level estimation, and bottom-up information influences the higher-level estimation of input signals. In the visual cortex, such schema suggests that backward connection from V2 to V1 would carry prediction of expected activity in V1, while forwarding connection from V1 to V2 would carry forward error signal indicating residual unexpected activity. This kind of functional asymmetry is the role of forward and backward central to the PP vision predictive processing. To test this idea, Raw and Ballard implemented a simple bidirectional hierarchical network of such predictive estimators and trained it on image patches derived from 5 natural scenes. See, using learning algorithms that progressively reduce prediction error across the link cascade and after exposure to thousands of image patches. The system led to user responses in the first level network to extract features such as oriented edge and bars, while the second level network came to rupture combination such corresponding to pattern modeling their large spatial configurations, for example. My predictive power over the predictive model. Hmm. Today we start studying earlier, by the way, guys. Alright. I kind of feel good every day when I study. The only thing I really like in my life is my studying routine. And I won't say much about businesses that I'm trying to build or the startups, but yeah, this is the only thing that feels productive and predictable and not too chaotic. And going to gym. I just love them. right, exercising. And yeah, today's the rest day, to be honest. So yeah, today we'll be reading a lot in the afternoon too, if I do find myself with energy. But yeah. Level, so yeah, surprising such a fixed naturally. Like, yeah, first forget neuron. The heart of the entire one. Once this clicks on my interface start making sense. First, forget neurons. Imagine you're trying to identify an animal in a fog. It'd be cat ears, fox, wolf, rabbit. You're uncertain. Then you see Itana. Now you're thinking, then you see Itana. Right, okay, this doesn't look like a fox, but yeah. Believe it is probably a fox that influences how you input in lower level details. This is exactly. Let's map this to the brain. Suppose light enters your eyes. The retina measures pixels. Those pixels levels up on low level sees just tiny edges. It has no idea what object. That's what retina is accepting. The next level says those edges probably belong to fur. The next level says fur probably belongs to dog. The next level says dogs are common in parks. Notice something, the highest level isn't predicting pixel. It predicts I'm probably looking at a park. Then prediction travels downwards. Park, dog, fur, edges, pixels. The lower level should observe. Context, objects, paths, edges, pixel. Each level predicts the one below. Suppose the highest level predicts park, therefore it expects trees, grass, dogs. The object dogs, therefore the feature. For legs, tail, the feature level predicts cut and edge orientation. Tell the brain. Doesn't tell the brain dog, it tells the brain here's some edges. Predicting natural images. Sensory input recognition emerges consequences that is radically. Predicts again the reality answer. The loop runs hundreds of milliseconds after milliseconds all the time. The brain is not building perception from the bottom up. The compression with prediction. Well, attention, immersive attention is like, okay, where do you constantly, what do you constantly feel uncertainty about, right? And that's where your attention kind of dives, and YouTube kind of like creates uncertainty constantly for yourself and then reduces it by giving you information. So it spikes uncertainty about the world, and then you're constantly trying to reduce. That's why those kind of things work so efficiently well. And how do you reduce uncertainty matters a lot, right? And whatever something like people, like the masses are uncertain about, right? Like that kind of like creates a lot of value when it comes to YouTubing or something, right? It's a big market. And but this about it and got this phrases in dogs, car, cat, trees. I should maybe I should quit my startup and go back to YouTubing or something. I can get it done actually now that I think about it. But yeah. All I like right now is just a camera for YouTube, right? Just one camera. I can buy an action camera or something. Which doesn't even cost that much, honestly. Okay, I'm biting my nails. I'm sorry for that. But it's a habit. It's completed. And the remaining nail goes on to this guy. I think they teach at school that you shouldn't bite your nails or something. Yeah, I probably didn't pay much attention to that. The entire descent, something here didn't match, right? Or but okay. You got to expect where is the hierarchy? Yeah, but where? Okay, we hit the limit. Where is the hierarchy? Self predicts. Two predicts. Two predicts. Sensory data. Every one of these levels is processing information. Should have similar brightness or the edges should continue. Passes you just read. Scale prediction, then the V1 prediction. Visual cortex, don't care about disorientation, simply got to imagine this. Predicts this image will probably continue. Combination, now you're getting close. Gene junction curve. Imagine instead of just line. Now prediction becomes okay, this then. This, and this. Ah, now everything clicks. Now everything clicks. I met my friends out and he's probably making coffee. The mug should be on the table. I'm just thinking. It's a loop. It's an ongoing loop of straight transitions. Cybernetics with law. But I think every layer in itself is predicting, like every part of the hierarchy in itself is like predicting the next state of the future. So it's not just that like retina, there's V1, there's V2, there's higher cortex, there's even like higher cortex. It's like every part gets information and is predicting. It's not like the only the higher cortex or even higher cortex is like predicting the things. Every part gets information, it predicts. And I think sensory errors could appears, like prediction error could appears at any layer, right? And the more layer you have prediction errors, I mean the bigger the violation, and the like the higher the surprise is or something. Prediction not centralized. It's wrong. I feel kind of hungry, even though it's not time because I woke up earlier today. I see now. I think this uncertainty lens will take a lot of time, but yeah. Yeah, thinking in terms of certainty is kind of stupid. Classical represent a field, but surprisingly short the missing represent the line gets longer. Such effects end with them. So yeah. Level 2 network, the strong firing of level 1 edge cells. I don't get this part though. Well, I don't get much of this part. Could you explain me that? Wait a minute, let me write something. And it's like, you know, guys, that's like we. Okay, I feel really hungry. I need to go downstairs and eat something, but it's like Yeah, I'll come back in a couple minutes. You're right, guys. I'll come back in a couple minutes. I think it's time for a 10 minutes or 15 minutes break. Okay, so yeah. Right, guys, so I'm kind of back. All right, so yeah, I was taking notes, by the way. So any behavior that persists. Feedback is information. Or something like that. All right. Let's see what's out, everybody. So that's why any human behavior that persists solely because it reduces uncertainty about the future states or something specifically to that, right? Yeah, I do know what he says. Let's come back to our topic, guys, I suppose. And I think tomorrow we'll have like working 3 monitors, most probably. Depends on the timing of the delivery. It would be like done till afternoon or something. So yeah, 3 fucking monitors. Oh my gosh, that would be so fucking beautiful. Like finally 3 fucking monitors running or something, man. I've been waiting for this since like for infinity or something. Hey. Can we get it like this? Oh, this is actually a very intricate design that I didn't realize, and they kind of like, yeah. So you get what I'm trying to say, right? So yeah, if you come back to the topic though, right, which is like a binocular rivalry or something like that, huh? Breathing processing has been restricted to few relatively low level phenomena. So your body's pretty much trying to like, do you know the split brain theory in which like you have multiple split brain? Of course, I'm not gonna be talking about like how that is legit, but what I'm gonna talk about is like you have a split brain. So split brain patients kind of like have rationalization for the things like yeah, because their brain is impaired with memory, so they start generating rationalizations for the behavior as to why, because brain always tries to explain away the sensory input. So they're kind of like creating a prediction, which kind of like explains the sensory input that they're getting or something, right? At their own sensory inputs. All right, so yeah. Okay. This is bad, but this is not bad, I suppose. Mm-hmm. Yeah. But I do not like the new positioning, honestly, of my mic. I guess this one is just far much more efficiently better, I suppose. How does it look? Yeah, this one just gets the job done. There's so much oil on my face and on my hair. I should probably get it clean when I take a bath or something. Yeah, no one's watching the stream, like always. So far, example of predicting processing have been restricted to few relatively low-level phenomena as a final opening illustration. However, it brings together many of the key elements introduced so far. Consider the Huawei et al. 2000 hierarchy predictive coding model of binocular rivalry. It is a striking form of visual experience that occurs when using a special experimental setup. Okay, is presented simultaneously with a different. Oh. This can be achieved by using two super image rendering using red and cyan graphics with special. Just like how can you like. 3 that was once understand right as stimulus the subject experience such as from the left eye receives an image of a face. Under these extremely important artificial conditions, subjects report a gradual. Was proven to be powerful tool for studying the neural. Use the incoming signal remain constant while the percept switches to and fro. This attention, however, the mechanism at play here is not well understood. The strategy is to take a step back and to attempt to explain the phenomenon from the first principle in a way that makes sense. Apparently, disparate findings, in particular, they pursue what they term an epistemological goal is to reveal binocular lively as a race of knowledge or in response to ecological unusual stillness condition. I just don't know why I like that though. Let me just quickly change that settings. No, not this. Show, right. Yeah, and let's just rotate it by 180 or 270 or 0. Yeah. Alright, so now it works like pretty well. Like, yeah, sometimes you just like, let me just do something for a sec. Yeah, you can see my only face though. Yeah. Exit. Now you can see me. Alright, so yeah. The strategy for this Sorry, once again, the emerging unifying vision of the brain as an organ of these model the task of perceiving brain is account for to signal to explain away. Yeah, to explain away. It's like, yeah, this line matters a lot. It's not like brain. It's just trying to constantly explain away, right? It's just, and the problem occurs when it can't explain away. Matching top-down prediction. The better the match, the less prediction error. Then propagates up the hierarchy. The higher level guesses are thus acting as predictors of the lower level processing. It remarked earlier of so-called imperial bias. Within such a multi-level setting, a visual percept is determined by a process of prediction of each considered with different type into mutually coherent predictive coding engine. Large scale hypothesis constraint that makes the best prediction, and that taking priors into consideration is probability. Other overall hypotheses at that moment are simply crowded out there, having lost the competition to the best account for driving signal. Notice the predictive processing cascade top-down signal will account for predicting those only elements of the driving signal that confirm to and are predicted by the current winning hypothesis. In the binocular rivalry case, however, the driving bottom-up signals contain information that suggests two distinctions. Will, for example, face at time t at location. I think first use ChatGPT to explain and then read rather than like, yeah. Like the point is like it's kind of fucking complex, right? This book. It's like each time I try my like I would save far much more energy trying to figure it out by myself. And be able to derive way much better meaning. Ah, that's just a wrong image I took there. Just make a fucking small control V. Element binocular rivalry. It's like you have a so could you explain what he's saying actually? I really want to just sleep. Like, want to do nothing. Just want to rest or something, if that makes sense. It should be appearing here, but it's not. Okay. Really don't want to read all that.
Perception is not simply caused by the sensory input. It is the result of a competition between different hypotheses trying to explain the same sensory input. Close quote. Let's build it slowly. First, what is binocular rivalry? Normally, both of your eyes see almost the same thing. You can see the code in our conversation history. Easy. The brain says, open quote, I'm looking at a tree. Now imagine an experiment. Your left eye sees face while your right eye sees house at exactly the same location. Normally, this never happens in nature. Now ask yourself, what do you consciously experience? Do you see inclinate? You can see the code in our conversation history. A face house? No, something very strange happens. For a few seconds, you can see the code in our conversation history. Then after a few seconds, you can see the code in our conversation history. Then you can see the code in our conversation history. Then you can see the code in our conversation history. Then maybe a mixture for a brief moment. This is binocular rivalry. Hat tack. Classical neuroscience had a problem. The sensory input never changes. The experiment keeps showing brain. You can see the code in our conversation history continuously. But your experience changes. How? Why? Clark says predictive processing has a beautiful explanation. Thash. Think like a scientist. Suppose I show you some evidence. The evidence is strange. Your job is to explain it. Maybe you propose hypothesis A. You can see the code in our conversation history. Another scientist proposes hypothesis B. You can see the code in our conversation history. Both hypotheses try to explain the same evidence. Only one can win. Clark says that's exactly what your brain is doing. And indeed, imagine the hierarchy. Highest level. You can see the code in our conversation history. That predicts. You can see the code in our conversation history. Lower levels predict. You can see the code in our conversation history. At the same time, another hypothesis says, you can see the code in our conversation history, predicts, you can see.
The problem is, like, there's so much code generated. It's like, Oh, I clicked on the wrong. But let's just not. Okay, I do get what you're saying now. So can you explain some parts? No, rest I'll just read it by myself. Maybe I should stop unnecessary highlighting. Yeah. There's some noise in the background. Not specifically a noise, but it's more like my parents communicating in the downstairs, and that's kind of making slight noise, and I can hear that. So can you hear those too? Even this is for sleep. I never sleep. This, in fact, this make me more attentive. So yeah. Yeah, I think you guys can also hear those noises because like they're communicating. So let me just like make it this like the stimulus, not the stimulus. Predictive processing make me say sound stimulus, but it's not stimulus. It's more like okay, they're making too much noise. Do I have noise cancellation on? Yeah, I do have. Yeah, even with noise cancellation, like yeah, I can hear them slight bit, I guess. But that's alright. Oh, someone did message. Okay, hello, Niktat. Like, yeah, OG Pro and whatever. Bro, you came yesterday too, right? Can you help me learn the C++? I'm the beginner. I mean, okay, bro. First of all, I did vibe code that. I mean, I do not myself, but I do know the basics of it because I did learn the Python and stuff like that. But AI helped me do that. So yeah. And by the way, this is like today I'm not gonna work on that. I'm reading a book about predictive processing. So if you do want to know that, then yeah, you can be. But if you want to learn C++ and something like that, bro, there's so much. Like no, I did notice yesterday too, you know. But it's just that you left. I'm concentrated in reading, you know. That's why I guess. Yeah. But if you do want to know C++, you can just watch YouTube videos, right? And you can just buy a book or something and read that. So like, okay, how was like, okay. Hmm. Actually, by the way, you're the first person to be live on my stream, so kind of like, yeah, that makes me kind of happy. Thanks for, yeah, just watching it for a little bit time. Despite this attraction. Do you want to earn money or something? You don't have to cry, buddy, you know. I'm just 16. Yeah, I'm just 19 too, but yeah. Earn, right? Aha, I guess I too also want to earn some money, right? I mean, besides the school and stuff like that, so yeah. But as for like, I would tell you like, if you're trying to learn C++, the point is not to actually learn code. The point is actually to build things that actually makes a lot of money, right? It's like, it's less about like it's more about building things that makes money. For example, if you're a business owner, right, you don't necessarily need to know, right, like how a monitor is made, like, right, or a mic is made. You do need engineers that make it for you. To learn it because you are the new one here. I see. Well, yeah, I'm also new to this coding and stuff like that, but like not that new. Like it's been 1 month or something. So like yeah, but relatively new compared to like experience, like you know. But I think like I am building something. It's like a sensor that like first of all I build like an IR receiver or something like that. That kind of like, but I learned like I think I got some information from cybernetics too, how feedback and control happens. So yeah, I think if you really want to learn, I mean like you should go with something as complex as cybernetics or something. But that would be too complex if you are like not into the kind of person who read a lot. I'm gonna start the journey to teach a little. No, no, of course not. Of course not. I have my own things to do and I cannot do that to just like, you know, that's kind of like a funny idea, but I'm definitely not going to do that. Right? I have my own stuff to do. And then like, yeah. Yeah. By the way, thank you for hopping around though. Explain this by these attractions. Hmm. First of all, I should add a notification or something whenever someone action times. Is there's no way to add a notification so that you know if someone actually sends a. Oh, there's even a chat, right? Concurrent view, one view. If you really want to earn much money, you know, you can just go with like a on C++ or something like sorry, freelance a website and then learn C++ and then kind of like skill. But I think like if you really want to learn like you know, journey to teach, it's like yeah, but the best or the most efficient way would be to actually learn it from the YouTube videos or something where there's a lot of tutorials or something. And if you do get stumble onto some problems, I would like just get a snipping tool, take a screenshot of whatever you do not understand, go to like AI or something. Like I would recommend ChatGPT or something because it has like a better dictate option and ChatGPT explains really well compared to other AIs. Right, so like go to that, copy paste that stuff. It's gonna get like it's gonna understand what you're trying to say. So that is a really efficient way to learn. Ah, oh, okay, yeah. Thanks for saying that. It's because of my mic. Am I audible now? Yeah, yeah. I think I should be like the reason why I decreased the audio is because I was reading and there was some background noise. So yeah, but now it should be all right, I suppose. Yeah. And plus, there's some background noise too that I owned up. So now that's gone. So now you'll be able to hear me clearly. Yeah, yeah. Yeah. Yeah, so as I was saying, if you really want to learn C++, then the most efficient way is to get a book. Okay, but then again, from the way you speak in chat, I don't expect you to have the best English, right, buddy? But like one of the most efficient ways is like you can have like a simple snipping tool, or if you're reading from the phone, you can just take a screenshot. You can just like take a screenshot of anything you do not understand and like copy paste that onto like yeah onto like let's say ChatGPT. I think the reason why you should be going with ChatGPT it's because like it's kind of free, right? And like if you do that analysis through screenshot, you would have to go to like a Gemini or something. I do have a paid version of Gemini too, but you know it's paid, and Claude 2 and Grok 2, like everything is kind of paid. So ChatGPT is the only option or the get go you can have. Right. So you can just go there and like yeah, I would recommend the best thing is to do is to like go with a book, or you can just go directly with But I would say it's like once you got the basics things, you should start like vibe coding or something. But in vibe coding, not essentially what like everything is done by AI or something. I think you should learn thinking in system because that was the first book we completed. Right now this is our second book. So like from that you can get a little bit of idea how systems are built. Right, like now I'm building an IR receiver system which like takes signals from your phone, sorry, not phone, sorry, laptop, and sends the signal to the laptop. Laptop sends signal to our receiver that sends signals to the AC. Is there AI feature in the Microsoft Visual Studio? Well, yeah, there is a like yeah, you can connect with that. You can use anti-gravity IDE. I would recommend that. Like if you have a Gemini Premium, but if you do not have, then like Microsoft Visual Studio, like yeah, works pretty good too. So you can just ask it to explain the code that you're. But the thing with Microsoft Visual Studio and everything, right? The point is like you have to go through the screenshot out is because you have to pay. So if you can pay, then you can go with like Microsoft Visual Studio. Like if you can pay some money, right? If you cannot pay any money, then you have to copy paste. Like yeah, take a screenshot. Yeah. Yeah, if you have money, you can definitely go with like a Microsoft Visual Studio, and then you can probably buy Codex or Claude like premium membership, and they can explain all the code, all the errors, all the bugs, why you get the bugs. You just need to ask better question, and the AI would explain majority of the stuff to you, right? And even if you're reading a book, or even if some topic you don't get from YouTube, you can ask it literally everything, and it's going to explain it to you, right? If you cannot get the premium, then only option is left is using ChatGPT or something, the free version of it. Yeah. And even though I have Gemini Premium, I'm gonna be honest. A lot of time when it comes to normal communication, I do use ChatGPT because I do think it has a lot, like especially when it comes to explanation. Like Gemini kind of like complicates a lot of stuff, and ChatGPT explain it such a simple way. Oh, I started with Microsoft Visual Studio, but right now I'm using Anti Gravity IDE. That works like way much better, right, in terms of like coding because like yeah, but Microsoft is kind of good too. And if you have multiple AI agents, then you obviously definitely have to go with like a Microsoft, like Visual Studio, because they have like a Claude Codex and like yeah, even the Google Gemini all integrated into one. So if you have multiple AI agents, you can pretty much use that to efficiently get the things you want to get done, right? The attraction, the And as for you said, like I didn't notice that was pretty much because kind of focused on reading the book. So of course it gets harder to kind of like notice people when you're really concentrated. But there are times when I'm not concentrated or just talking. Those are the times when I really like yeah doesn't pay much attention to the book. So that's when I can answer you the best. Right? So where was I? Will this make account different in tribal? So what the post kind of direct attention mediated efficiently. Yeah, I do, right? I mean, you can watch the live stream on the synthetic channel, not on this one, like Varik.Verilion, this one that I am kind of like uh you know live right now. You can definitely watch on that one, and like if you really want to learn to build systems, right, I would be learning from like creating things from scratch. As long as you understand my English language a lot, right, it won't be much harder. Like over time you do kind of like learn a lot of things. Oh, wait a sec, my where is it? There it is. Right. So yeah. Finally. Perfect. There is the AC remote. And one more thing, you should add some calm background music during the live stream. Right. This way people won't. Yeah, right. I mean, the point is like, it's not for entertainment anyway, but you are kind of true about that. Like some background noise do help when it's kind of calm. The one that I have right now, like the distant thunder. Right, I kind of like turned it off, but yeah. And kind of like helps me read too, actually. Not gonna lie, kind of like cuts off the background noise. Whew, yeah. And the point is, the funny part is, people. What I did realize is like people do not watch live stream when it comes to like educational videos. Like they would watch a gaming live stream or something. So the market for it is kind of slow, right? Or kind of short. And the reason why I live stream is not because to get views or something. It's because like it kind of like, especially if there are people who are interested in the topics I'm interested in. So over time, what happens is like you have a portfolio. All right. So for example, from portfolio, I mean, you can just always say, not for but adding BGM will increase engagement. Yeah, that's true. Right, but the thing I'm saying is like this kind of like acts like a portfolio, just like you have LinkedIn, right? Like as a portfolio. But this is like if you have like 1,000 years of reading books, right? And this is what you have read, and one day, like even it's become increasingly harder to deny the proof, right? So even if you do not have a degree or something, it's like if you do one day go out there into market, like people can just you can just pretty much show much your account, even if it doesn't have any views, the data amounts to something, right? And they can just look at it, whether it's like you coding stuff and learning stuff, and or just reading books. Like it becomes like kind of obvious that this guy knows a lot or understands a lot, right? Yeah. And one of the biggest reason for this live stream is like, the main reason is to not be dumb, right? And it's to get more smarter as the day goes by and have more better moral of reality that allows me to understand a lot of things that's going on in our world and surrounding. That's why we are reading this like power of prediction, like yeah, how brain functions and stuff like that, and how does it create hypothesis about the world and how does it test on that, which is entirely different project or a hobby compared to my main thing, which is not main at all. I mean, I'm not that old yet, right? I'm still young, and you're especially even more young. If you get into reading books this early, right? I mean, I got into reading books a long time ago, right? But for a long time, I think like one of the biggest mistakes that people make when they are like reading books is like they would read like self help, or they would read like a simple stuff, right? Maybe literary fiction, but at the end of the day, it's not about like it's about reading things that are beneficial, extremely beneficial to you in the long run. There are very few things that are extremely beneficial. That means there are some things that talks a lot about computation. As you see, like civilizations are getting more and more technological, right? So if you have read a couple of books on computation in a year, that is advantageous for the next 50 or 60 years to come. You have an edge, right? You have some difference compared to other people, which gives you some advantage, right? The society is getting more and more like understanding of human biology and stuff like that. So if you know about a little bit of things of health, like about health or something, what that does is like over long periods of time you can actually maintain good health, and especially when you're old age or something, that gives you a lot of advantage, right? So that's why it happens to have with health there are a few topics like that comes with the brain, like how brain predicts the world, that tells you about why you think the things you think, why you feel the way you feel, like how you deceive yourself, how biases emerge, like how people constantly lie themselves, manipulates other people, how they constantly try to reduce uncertainty, how they have a hypothesis, how there's multiple strategies to reduce uncertainty, a lot of stuff about brain, right? So it's like, what happens if, let's say, you read about just one or two book a month? That's about like on surface it seems really slow, just 2 book a month, but in 10 months it's like over a 20 books, right? And in 10 years, if you just like do an approx, it's more than like a 200 books a year, like, sorry, in a decade. So like by the time I would be, let's say, 28 or 29, I would have read more than 200 books, different, ranging from different kind of things, from biology, from computation to physics to math, and different kind of stuff, right? Like from brain. So what happens in the next 10 years, you get increasingly more and more smarter. Okay, you should live stream from Twitch, that it helps you to connect with Chinese people. I see. Well, yeah, that's true. But okay, what would Chinese be doing? I mean, so Chinese people do also study live stream or something like that. I didn't know about that. And the reason why I did a live stream on Twitch is like on Twitch, some Chinese clients and international clients. Yeah, I do think the biggest problem that by my live stream is not getting any views is because I live in India, right? So like, it only recommends to people of India, and as long as you're like talking in English and communicating with a lot of complex stuff, like a lot of Indians are not interested in that. So that's why like the large variety of the market I hit kind of like doesn't actually ever receive, like, yeah. So maybe I can live stream on Twitch if it helps a little. Yeah. Though I would now get back to reading, I was like, no single hypothesis account for all data, so the system alternates between the two semi-stable states. Oh, YouTube is banned in China? What? What? Oh, didn't hear about that. They have banned it? I guess they don't want their youth to be like, be a YouTuber or something, especially to that specific. But they have Twitch. That's kind of like, doesn't make much sense. They don't have YouTube, but they have Twitch, huh? Taskbar settings. Let me just do something. I'm not able to taskbar behavior, automatically hide taskbars, right? Yeah. I'm not able to select the chat here. Yeah, I'm not able to select. Yeah. Finally, the problem is fixed. Whenever do you live stream on Twitch app, do not forget to tell me the name of your channel and tell me your first subscribe. Oh, you subscribed me? What? I didn't check my analytics because I didn't have much high hopes for it. So yeah. Thanks for that. Nikat OG Pro or something. Like, yeah, if let's say in a couple of years I do kind of like make a business, and if I do get like a lot of knowledge in something, and if I do reach a big position, I mean, of course, why would I forget you, bro? Like, yeah, uh, Nikat, like, yeah, I don't know how to pronounce the name, but yeah, Nikat OG Pro or something like that is like your name, right? Yeah. I mean, kind of funny. Yeah. Huh. Well, actually, yeah. Do you watch a lot of educational videos, by the way? Like, just say yes or no. That would be more than enough. Because if you do watch a lot of educational videos, then YouTube would know that from your subscribing, it gets signals that, okay, my content would be watched by people who watch educational content, right? So you're gonna recommend it to more and more people like you, right? So at the start, like, this is the bootstrap problem with the YouTube. It's like it doesn't know whom to recommend your videos to, so you have to add a lot of videos or something for it to have an idea. If you do not watch it, like educational video, that's all right too. Actually, I don't really mind, but yeah. Bistable system minimizing prediction error. Described as the energy landscape containing a tuple file. What makes this account different from its rivals? Actually, is that where the point? Between the links and the hypothesis. Oh yeah, this is where my attention is going about attention allocation. Yeah, I guess like yeah, YouTube did find out. So I guess it's not recommending to random, like yeah, I suppose strangers or something. Between links set of hypothesis. Between inputs. Link sets of hypothesis. Selection. This competition is to selectively suppress the prediction error associated with elements of driving sensory signals. Hypothesis, but this top-down suppression leaves untouched the prediction error associated with the remaining house signifying elements. The system to explain in a way that overall interpretation was switched. The reading of inconsistent stimuli. It's trying to explain away a certain form of stimuli, and in doing so, the problem occurs is that you? Oh, what do you mean by that? I want to become like that. Like what? That? What does that mean? I want to become like that? That? What is that? Like, is that a typo? I think that's a typo, right? I want to become like you makes sense, but I want to that like what does that mean? Or some. Oh, that. Okay. You want to become like me? Why is that, buddy? Like. You can give me an explanation. I mean, if you wanna. Under some circumstances, do we know simple experiences? Oh yeah, English speaking, right? I think that happens when you read a lot of books. So if you kind of like get into reading books one day, I mean, yeah, you would be able to speak like me, you know. Part of the general law that, for example, houses and face do not be treated as nothing much, just a high school dropout. Well, I'm 19. I'm not doing anything. That's the thing, right? I'm not doing anything. Though I would be doing things soon enough. Like, yeah, building a app. That's literally the entire first channel is about, right? The synthetic one, the one that you got recommended to get a living or something. Though, yeah, if this doesn't go well, I mean, the next year I've took like 1 year drop. Like, if this doesn't go well, if this year, then I would most probably go college. But yeah, at 20, which would be a year late or something compared to the people. But that's all right. I did really wanted to experience, like, like what I can do in a year with by myself. And if I do get convinced that I would be able to do a lot of things, you know, then I would, like, yeah, not go to college. Though I do think self education has its own advantages too. That's why I'm kind of like going on the route of self education rather than using the education systems, right? What about you? What are the probability of both the house and face being localized in time? Hmm. Additional resources. Oh yeah, you did told me that whose treatment requires additional resources. Hmm. Oh, these active visual. Okay, I didn't want to highlight that, but I. Moreover, the active visual exploration of present and scene implies the fact that we can only visually explore the scene in ways shaping our experience. Action-oriented predictive process. Okay, suppression selection. That's all right. It's all right. You know, this channel was like wasn't really meant to connect to people, right? It was meant to record me and my study sessions, literally. And people coming was just a bonus, right? Prediction error. To the extent that which makes matching actually the driving certainly singles are suppressed or damn those aspects of singularity sometimes said or explained away. Oh no, you're not bothering me. That's all right. Well, you're my first viewer and subscriber, so how can you bother me? Well, you know, that's all right. Like, yeah, but it's kind of like obvious that I won't be able to talk throughout the entire time because, like, I do have to go back to studying too. And yeah, but talking sometime here and there, I can just catch up in the afternoon. Though I would be stopped streaming up at that point. Oh, I need to go for the lunch too, man. Yeah. So by the way, what do you want to do in life? Nikat OG Pro. Do you want to earn a lot of money? Do you want to make your parents proud? Do you want to what do you want to do in life? have any idea? Are you there? I guess you aren't, huh? This kind of explaining away is important and central. Models are correct, depend cues. Join in Microsoft, huh? Why do you want to join Microsoft? Like, it makes reasonable sense to be a game developer and a software developer, but why do you want to join into Microsoft? Tribe. Do you want a tribe? Like, tribe of smart people or something? If you really want to join Microsoft, then go get into a good college and then go through all the routes. But yeah, I can help you learn things, but I cannot help you join Microsoft. For that, you need to get good grades, right? You need to go to the school, go get to a good college, get a good degree, maybe from IIT, MIT, or some good university, and then hop into Microsoft or something if they select you after the interview, right? Build up a little bit personality, maybe a good portfolio, and most probably you get into the company. But yeah, if you really want to go into Microsoft, you can just learn C++ and but the thing is, like, like I would recommend you to, not go, like, because if you see online, like, layoff. Okay, let's just, since we are now talking and not actually paying much attention to studies, let's just do something. Well, is it necessary to? It's not necessary to learn English, honestly, but you won't be able to communicate well with the people there, right? Like, yeah, there is Microsoft in India too. Okay. Okay, GPT, could you tell me, like, how many layoffs does Microsoft had of, like, computers, like, of software developers in this year? Like, yeah, let's just do some research, man. Let's just do some research. But problem, 8,000 US employees who met current requirement. This is one not a layoff. For then, yeah, so 2.6% of global workforce. This hits. You can see, right? Companies like this are not actually, reports indicate that layoff affected manager, designer, market sales. Like, yeah, so big companies do a lot of layoffs, right? I mean, I don't really get the thing. Like, you can be, like, why do you want to get into a big company that actually, like, kicks out people, right? And there are people who actually competes that for those company for years. Shouldn't, like, is it for money? Is it for, like, because you feel like Microsoft is great or something? If it's about money, then you can build your own money. You can build your own services and website or something like that. Right, because in Microsoft has big criteria. Let's say, for example, you're on an interview and you cannot even speak English well, then that's going to be really effect, right? Because, like, in companies, when you're working with people, it's like a lot about English and communication. If you do not even have the basic thing, and on the top of that, there's a lot of things that they require for you to have. If you do not have those things, they don't kind of like care and they kind of like kick you out, right? Like, if you really want money, there's way more efficient ways you can learn, like, or to, like, earn money through, like, yeah, if you want to be game developer and software developer, that doesn't change the things. You can just, buddy, like, in fact, I would say, like, you could learn it right now, right? And you have 11th grade or something. Like, you can literally start building things, right? I still haven't earned any money, so I cannot be confident, but I do have a lot of confidence in, like, you can build your own game on stream. You can have your own services. You can have your, like, something like that. Why work for a company that just pay you some, like, money? Because it will be kind of cool for me, and my mom and dad will be also be very happy, right? But okay, that's actually a good thing, right? But yeah, that's actually a good reasoning, I guess, for you, I guess. Hmm. So you want to make your mom and dad proud or something like that? They would be proud if you earn a lot of money, right? They wouldn't be proud if you got kicked out of the. But yeah, it's not happening for everyone. So hope you perform well and become a good part of the company or something, if you really want that deeply. Now, by the way, it's my lunchtime, so if you are watching the stream, I would be half like, yeah, if you really want to talk more or something, I mean, I would be back in like some time, I guess, like maybe in half an hour or something. I would gonna eat the lunch and then I'm gonna stream till 3:30 or something. So like that would be 1 hour or 1.5 hour of more stream. So yeah, nice meeting you though. If you leave, that's all right too. Bye bye. Well, the first person I knew, right? The first person to come to stream would don't necessarily be a small person, right? They could be kids too, I suppose. Minors, I guess. Though we can't just underestimate minors these days, but then again. Yeah. Mm-hmm. I do have what they call. Mm-hmm. Hmm. By the way, tomorrow is the day for our 3 monitor setup to be completed. Oh my gosh, I just can't wait. Tomorrow is the day we just need to get our driver installed. Right. It shows 2 views. I don't know who was another person who watched it. Right. It's great that people are watching it to some degree, you know. Suppression and selective enchantment, right? To select. Yeah, because of them, though, I wasn't able to concentrate. That's why, like, only open the chat if there is some concurrent views, I guess. Like, simple heuristic I can make. Represent the world in perception. If these models are correct, depends crucially on coaching. I've something stuck in my teeth. I do have what they call. Wait a sec. This. I think this you call this floss, right? The only thing the guy that came into the stream was impressed about is my English. It would have been great if they were interested in Buck, though. And do you guys see the paradox, though? I must say, is that like the guy who actually reads a lot of books doesn't watch streams, right? So I knew it from the start that there's a high chance that no one would be watching the stream, you know. So yeah, I'm not pretty like sad about it, or I'm not really trying to get a lot of views. Though I wouldn't mind if I do get views, some views. Like yeah, suppression and selective enchantment. All in perception of these. Are explained away. Succeed. That means you're living in a bubble. That's kind of explaining away. System is kind of bad. So it's like you have like system 1, which gives basic, like, you know, system 2, system 3. It's like this is make the first prediction P1. This makes prediction over like yeah the P2. So this like kind of like propagates error, like yeah, and they kind of like reduce uncertainty. Like this is like P2, like the P3. Sorry. So it's like this reduce right in this uncertainty. It's like before, and this try to reduce uncertainty in itself. Like, okay, so every system here is trying to reduce uncertainty. I guess that's their motive, right? Like, whether they like it or not, I suppose. But at the end of the day, you just can't know, right? I mean, like, you can't know for surety. I mean, what's actually happening and what you think is happening. They can be like different. Show, then, right? Feels good, right? Ha 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 ha. That doesn't actually. Hmm. Yeah, though I guess okay. It's my tablet is the opposite, but this is like system A beats into system B beats into system C, and this is A, this is B, this is C, right? And then you have eraser that erases everything. This kind of explaining away is important and central, but it needs very careful handling. It is important as it reflects one characteristics. Wait a sec, I really want to check something real quick. Finally, I would have data. Let me open up this and let me just there is a slight bias here. Even more down. Yeah, I see now. So this is like how it works. Alright, so yeah, this is how it works. Let's get back to our job though, of understanding and computing reality. It reflects one characteristic property of predictive processing models. Encoding efficiencies that these models exhibit, since all that needs to be passed forward through the system is their additional error signal. Unexplained. I have been matched. Architecture, one that at each level estimation of error and feature sensory uncertainty. It really gets compressed, suppressed, explained away, or cancelled out is the error signal, which in these models depicted as computed by dedicated. Linked to but distinct from the so-called representation unit that encode the causes of. I think we have read a lot of the stuff. I guess oppression and selective enchantment. Encoding, inference, and Bayesian brain. I think I want to know where the second chapter getting the gist. When prediction misleads. Noise signal attention. Yeah, this chapter is actually really important. We have noise signal and yeah, and I wonder what a chapter 3 would look like. Okay, yeah, the book is getting surprisingly more complex, and then the imagination. Construction industries. Ah, how does imagination happens all the time? I think this is one of the most asymmetric insights I could get on imagination, because I do have fantasies and certain specific things like that. Embodied prediction action machines. Oh my gosh, yeah. So how do you predict and constantly try to reduce uncertainty about your actions, right? It's like, yeah, and how the loop functions and how all of this is going, and like, yeah, precision flows. Okay, yeah, that's another like a good how we perform actions in okay. Go back up. The book is really thick though. I didn't know the book is really no. The book only has 400 pages though. That means it will take about a month or something to complete this bad boy. But yeah, you get the gist. Okay, nothing is actually loading now. I was on 33 if I remember right. And this is the kind of book in which, like, if you just get a couple of pages every day, that is more than enough, right? Oh, I was pretty much far ahead in the book. I didn't know. There's something what I learned today, the prediction multi-level hierarchies and stuff like that. And friends, I mean, we're gonna start again from separation and selective enchantment, but we're literally gonna go down to here. I think this is the chapter 5. Also, creeping up on consciousness, expecting ourselves. Ah, identity, yeah. This is where I should be doing this, I should be doing that, encoding like the patterns that are encoded. I should be studying, I should be reading, I should be building scaffolding, prediction, the lazy predictive brain, and then there's systems and like how you constantly try to, I mean, this is one of the most intense dive on like a fundamental book on like being human. This is the shortest chapter conclusion, the future of predictions. He pretty much tries to, like, I've already read a lot of this book. What? I should wait and watch, right, guys? I should be getting up, like, catching up in a minute or two. Getting the gist. Okay, yeah. Here on page 53, though. That's like a good steady, like, yeah, we have done today. Honestly, not gonna lie. This is like really complex stuff though, kind of like buzzes my brain. Oh my gosh, I think I gotta sleep or something. So yeah, this is all for today's stream, I guess, guys. So yeah, good night. Right. Oh, good. It's good afternoon, by the way. But oh no, yeah, it's good afternoon. But yeah, good night, by the way. Yeah.